Finding the trigonometric function values of an angle using reference angle.
In this question, we have to use the given information to find the other 5 trigonometric function values of angle theta. First things first, we have to draw a perpendicular line to put the right triangle in quadrant 1. So, since sine theta is 3/5, how do we figure out the rest? So, we have to use the SOHCAHTOA. So, sine is opposite over hypotenuse, and the opposite of theta is 3, and the hypotenuse is 5. Now we still have to figure out on finding the missing side of this right triangle. So we have to use the Pythagorean theorem. Therefore, our answer would be 4. Now we can find the other 5 trigonometric functions. We already have our sine, which is 3/5. Our cosine would be 4/5 since it's adjacent to the hypotenuse. Our tangent would be 3/4 since it is opposite over adjacent. Our cosecant would be the reciprocal of sine. So our cosecant is 5/3. Our secant would be the reciprocal of cosine. So it is 5/4. And lastly, our cotangent is the reciprocal of tangent. So our cotangent would be 4/3.
For number 2, first we will draw a perpendicular line on quadrant 2. After, put the right triangle in quadrant 2 because the question says it is in quadrant 2. Next, put our theta. So our tangent and theta is equal to -7/24. So the tangent is opposite over adjacent, and it has to be positive since the y-axis is positive. Then 24 has to be negative. That's how I got -7/24. Now we have to find its missing side, which is the hypotenuse. So we have to do the Pythagorean theorem. Basically, the Pythagorean theorem will make the missing side 25. But to solve it, it's 7 squared plus 24 squared equals c squared. Then, when you solve it, it's 625. So our c is equal to 25. And now, remember that our hypotenuse is always gonna answer to positive. That's now the missing side. So now, we already have the given value of the measurement of this right triangle. Now, we have to find the rest of the trigonometric functions. So our sine theta is opposite over hypotenuse, which will be 7/25. Our cosine theta would be adjacent over hypotenuse. Since 24 is negative, our cosine would be -24/25. Our tangent is already given, so we don't have to find that. Now, we will find the rest. Our cosecant of theta is the reciprocal of sine, so it's 25/7. So instead of SOHCAHTOA, I use CHOSHAKAO. It's the opposite or the reciprocal of sin, cos, and tan. So now, we will find our secant of theta. Our secant of theta is the reciprocal of cosine, which is -25/24. Then, our cotangent of theta is also the reciprocal of tangent, so it is also -27. That's all. Thank you. For number 3, the procedure is also the same, but with a different given. So again, let's draw a perpendicular line and put the right angle in quadrant 3, as said by the given. Also, put our theta. Our cosine and theta is equal to -15/17. Our cosine is adjacent over hypotenuse and is negative because of the x-axis. And 17 is positive since it's a hypotenuse. Next, we find the missing side, which is -8. It is negative because it's in quadrant 3. Now, We have our needed measurements to find the trigonometric functions. So, our cosine is given. We don't need to find it. Our sine theta is a missing side, which is negative 8 over a hypotenuse, which is 17. Our tangent is also the missing side of the triangle over the adjacent of our triangle. Our cosecant of theta is the reciprocal of our sine, so it's negative 17 over 8. Our cosecant of theta is also the reciprocal of our cosine, so it's negative 17 over 15. And lastly, our cotangent is the reciprocal of our tangent. That's all.
We have to use the given information to find the other 5 trigonometric function values of angle theta. We have to draw a perpendicular line to put the right triangle in quadrant 2. Since cosecant theta is equals to 41 over 9, it is the reciprocal of sine. So it is hypotenuse over the opposite of theta. We still have to figure out on finding the missing side of this right triangle. So we have to use the Pythagorean theorem. Therefore, our answer would be 40. You might be wondering why it's negative 40 because it is on the negative side of the x-axis. But the thing is, the hypotenuse always remains positive. Now we can find the other 5 trigonometric functions by using VSOHCAHTOA. Sine theta is the reciprocal of cosecant theta, which would be 9 over 41. Our cosecant theta would be adjacent over hypotenuse. So our cosecant will be negative 40 over 41. Our tangent will be opposite over adjacent. So this will be opposite over adjacent. And our tangent of theta will be negative 9 over 40. Our cosecant, of course, is already given, so it is 41 over 9. Our secant is the reciprocal of cosine, so our secant would be negative 41 over 40. Our cotangent is the reciprocal of tangent, so our cotangent would be negative 40 over 9. So this is it. We have found the rest of the trigonometric functions.
How? I got the 6 trigonometric functions. So first, our sine would be negative 15 over 17 because it is the opposite of the hypotenuse. Our cosine would be 8 over 17 because why? Because 8 is adjacent to the hypotenuse. Our tangent would be negative 15 over 8. Why? Because it is the opposite of the adjacent. Our cosecant, it is negative 17 over 15. Why? Because the cosecant is the reciprocal of sine theta, which is negative 15 over 17. Secant, we need to find, it is the opposite of cosine. So the opposite of cosine is 17 over 8. So that is our secant. Finding our cotangent, it is the reciprocal of tangent. So the opposite of that. So negative 8 over 15.